Greetings everyone and welcome to the first show of BusinessTech Times. This is a show where we invite inspirational guests to talk business and tech development. And this first episode we're recording at the OF offices in Gothenburg, so big thanks to them for letting us record here. We're very happy today to have our first guest of the show, Forsberg, who is a senior expert in robotics and AI. So a warm welcome to you.
Thank you.
How are you today?
I'm fine. I had a wonderful day. Sunny autumn day in Gothenburg.
Nice. And yes. So finish the day off with some podcast and then we can...
Yes.
That's nice.
That's nice.
Yeah. So Hans, you started with robotics as a very young boy, I guess.
Actually, my parents gave me a electric building kit
really?
on my 6th birthday.
Yeah, so you started already there. And since then, you worked with different types of projects and, how do you say, different...
Yes. Well, I spent my whole life building stuff. So this is the passion from this kit were just to taming the electrons. I just can't get rid of it. So I built several autonomous systems. I've been working with, for example, I've been working 15 years in the domain of domestic robots, typically vacuum robots and lawnmower robots.
Yeah, so one of those that you can see in like every two gardens nowadays.
Yes,
yeah,
so I spent a lot of time in research and development to trying to make these machines smaller and more autonomous and intelligent than they actually are currently. So that's one of the passions. And then I have a good education to that and a lifelong experience within robotics and now the last 3 or 4 years I have the opportunity to work with brilliant colleagues who knows about AI and machine learning, and I try to find a role within this domain. And that's what I'm doing currently. Yes.
So a journey that has brought you from building kits as a young boy to neural networks and pushing the AI agenda today.
But keep in mind, it's still the electricity.
It's still electricity.
That's billions of transistors and stuff like that. But it's the same idea.
So experience from both consulting and project ownership across industries as well.
Yes.
But today, when companies come to you with this experience and this insights, what do they actually want? What is the value you could add to their business?
Yeah, some of the customers of course know what they want, and a lot of companies don't really know, and some companies we visit and try to tell them what they can use this for. I mean, OF is a huge company with 17,000 employees, and we are working all the domains of industry, more or less. So that's really interesting. And that way we can find new, interesting projects and clients all over the whole industry area, really.
Yeah. Would you say that more companies do know what they want? Or is it the opposite, that they're more exploring and trying to find out what AI and...
Most companies don't know, and there's a lot of companies also kind of afraid of and scared, and so that's what we do. That's one of my jobs, to visit companies, and I have speeches and I have tutorials where I try to show the customers that AI and machine learning is not necessarily beating a Korean master in Go with a super big and expensive computer. It could be such as simple as just optimizing a more simple task in a control system or something like that. And so that's what we're trying to do. And we have a very pragmatic approach, I would say, from the Gothenburg office. There are AI departments within several OF offices. And the Gothenburg office tend to be pragmatic. And that might be related to the fact that we have a lot of industry in Gothenburg. We have the automotive business, and we have some other more manufacturing businesses. And our Stockholm office might be a slightly more academic, and that's suiting well because they have the opportunity to approach like big banks who tend to have the main offices in Stockholm, and insurance companies, etc.
Okay.
So we go pragmatic.
Okay, so when you visit these different shows, what is it that you actually do? You said you had speeches and you go pragmatic, but what actually happens when you go tell them what's happening?
Yeah, that's one more high-level approach. But then when we meet the customer, we try to tell them that, okay, there are so many new opportunities within machine learning, AI, and not necessarily machine learning AI. I mean, math and statistical methods they have also developed the last 20 years, and machine learning and neural network is just one of these new techniques that might be applicable for the customer. And then so from our point of view, or my point of view, I have help from, I think we have 5 or 6 data scientists with really sharp state-of-the-art skills from academic research, etc. And then we have a few senior guys like myself, and we try to get all these bits and pieces into the real world, to get our hands dirty and to find, together with clients and customers, to find things that we can enable in current products or in forthcoming products, new products. And so when we try to sort of release these opportunities, we quite soon realize that, okay, from my point of view, quite often the neural network is the enabler of a new opportunity or feature. But then, as always, we end up with tons of more traditional coding. It's front end, back end. It's a user experience thing, the graphic user interface.
Whole 9 yards,
And then there might be some hardware things. And then if we go even deeper into productifying, there is certification, validation, a test program, etc. So keep in mind that the neural network or some other modern math method is often the sort of the core of this, and then it grows as always, and then it's a good thing to have thousands or at least hundreds of IT colleagues surrounding us.
Of course. Do you have an example or a case where you can share like how the neural networks can unlock new businesses, or?
Well, there is an example from the energy side where I'm working in a building project from a Stockholm big real estate company in Stockholm, and they are building a high profile, more village of 500 flats, and it's a very high ambition on sustainability and low CO2 footprint. They have a quite advanced energy system with a lot of thermal energy, very large area of solar panels, etc. And they plan to store energy in hydrogen and batteries. However, we found out that there might be a way to optimize the energy consumption by more or less creating a digital twin of the energy consumption of the site. And that's actually, I started my professional career after my education within this business with heating, ventilation, air condition, or HVAC, or what it's called, some 35, 40 years ago, something like that. And it's amazing to see that the same dream and issue and the idea of looking ahead and knowing the day before what your energy needs would be tomorrow. And now it's feasible. And that's not that magic really. It's more like a desktop case it's like a Kaggle competition. It's very, very well defined, and we're working with that right now, trying to build that model. And it doesn't necessarily have to end up with a trained network. There are other cool methods that my colleagues, the data scientist colleagues, know about, but we'll see where we end up.
We'll see.
So you have to. I also learned from a lot of my customer meetings that there is a gap between the idea of the sort of general idea from the public about AI and neural networks, machine learning, and what it actually is. So a lot of people think that, or even professional customers, they think that it's okay. It's still out in the blue, and we try to show them that, well, it could be something smaller.
Okay.
And that's one of our specialities, to squeeze the network down. Training still will require big computers. You might get it from the cloud, or you build your own machine with a lot of graphic cards, etc. So that's still tedious and advanced, and my data scientists are the guys who can help me with that. But then to squeeze it down, this is an example of a small sensor we're working with right now. It's a prototype where we're actually running a neural network. Yeah. It's identifying and classifying people, dogs, cats, bikes, motorcycles, cars, whatever you like, actually. And by using a brand new type of microprocessors called neural processing units, we can actually achieve quite high performance on an embedded device, and we can build them cheap. So this is running on an Intel chip, a so-called neural processing unit, and we also build devices around Google's latest chip called the TPU. And so that's one speciality. But of course, we also go for the big projects and the big statistical issues. Yes.
So when you say that you show them people or animals or so, I guess that's not the implication that they want in the end. So what would that actually mean for a company?
And that's the thing I learned too, that when I meet customers, it's really valuable if I can bring a use case that is really close to their core business. Yeah. And so I've visited people working with wastewater management lately, and we had opportunity to come up with, or to bring them a real case based on a client to them who had a small problem or a small issue that was unsolved, and my data scientist colleagues looked at the case and said, okay, we can solve this. So I had a meeting where I introduced them into the technique of neural networks, and then I had some other use cases more fancy with epileptic seizures, detections and stuff like that. And then I ended up with this more pragmatic case based on their own domain. And that's good, and that's what we have to do even more. It's a lesson learned that I'm focusing on right now.
So it's bridging a gap.
Yes.
Yeah, it can help. So I was thinking, because you tell that you visit a lot of companies, some think they know what they want, some don't at all, and then you can use these, or in both cases, you can use your applications to show them perhaps what they want, more or less. But when you come there, are companies actually ready for AI? There's also this split image that you talk about, like some think that it's something that we're not doing, but you show that it's very pragmatic, that you can do it today. Are companies ready for it?
No, they aren't. Many companies aren't. And in some cases, they are surprisingly negative or unaware of the opportunities. And even I visited a company working with domestic robots, like robotic vacuums. Yeah. And for us working with this, it's obvious that AI and machine learning will enable tons of new features. I mean, even though a robotic vacuum of today is navigating with SLAM or a visual SLAM solution with a camera looking at the roof or something, they're still quite stupid, and they know where they are, but not much more. And the first thing you have to do before you start your robotic vacuum is to more or less clean up your home. Get all the socks and underwear away from the machine, and it shouldn't be impossible for the machine to do that work itself. Yeah. And AI and some vision system, of course, could track and realize that this is not supposed to be here, and it could bring all those socks and stuff into a basket somewhere in the room. But when we met up with this customer, they said that no, we looked slightly into AI, and it's nothing for us.
Okay. Why do you think that is? Since you can clearly see the picture.
We don't really believe that it will do the trick, and so I was surprised, and but luckily enough, I gave it a second shot and asked them, okay, but do you believe in autonomous cars? Yes, of course, they said. Do you think we're stupid or something? Well, so then I politely and very diplomatic started to look. So you think that a 2-ton device, like a murder weapon at highway speed, could sort of be automated, fully autonomous, and it should know the speed limit, and it should do proper things at the traffic light and the crossing and the zebra crossings and pedestrians and car and bikes and dogs and cats. Yes, of course. Everyone has heard about autonomous cars, and maybe that was it. Everyone has heard about autonomous cars. So if you hear something, even though autonomous car is really magic for me. Yeah. It's unbelievably cool, and I don't know, maybe I don't believe in them either, but I heard so many talking about it, and I've seen it, and I rode the Tesla early, and my Volvo is driving itself to some extent. So by hearing things over and over again, we start to believe in them. But the thing of taking this experience or the thoughts you have about autonomous cars and apply them onto your vacuum robot wasn't obvious, because that's what I said. So okay, you believe that when do you think it's gonna happen? And you can say anything you like except never. So it's just a time frame. Okay, but from that point of view, don't you still think that controlling a small, super undangerous device in a closed compartment at turtle speed, and so couldn't harm anyone? Wouldn't that be possible with AI, you think? Maybe. So it's kind of telling that we have to tell the market over and over again, and we have to tell them with simple, hands-on examples. Examples ideally based on from their own domain or something like that.
Okay, so the biggest obstacle there might be that they, if I hear you correctly, it's unknown territory to another degree, whereas we heard, or perhaps
I haven't
semi-unknown for them.
I'm not a sort of human behavior researcher. No. This is my experience. And when this idea of, so do you believe in autonomous cars? That was interesting. Yes, of course. Because they heard it so many times, and they heard it from so many sources. Yeah. And they don't think whether they will come or not. They're more interested in who will be the first and what will it cost. Do I want one, or do I want to ride my car myself? Yeah. But the fact that they will come is obvious for them. And then apply that onto your own domain, even though it's close, like you're actually working with a domestic robot. Not obvious. Yeah. So over and over again. Yeah, because autonomous cars we have heard from like cartoons when we were younger, like look into the future. But then they were science fiction.
Then they were science fiction, but we're getting closer.
Yes.
But for you then, looking ahead, as the last part of this interview, what excites you in your work? Like, what is on the horizon for you? What gets you up in the morning and like, oh, we're getting closer to that?
I'm happy as it is to some extent.
Yeah, of course.
I often say that I'm old enough to experience the introduction of computers. I built my own first simple microcomputer back in the 80s, and then I had some of a predecessor of the VIC-20, or what they call. And so I've seen the computer revolution. I've experienced the credit card going electronic. I've experienced the cell phones, the internet, and now I'm experiencing the opportunities of neural networks, machine learning, and all those new math methods. But nothing has been as astonishing to me as the neural network AI thing. It's stronger it's more shaky or more impressive to me than any of the other revolutions or the other giant steps I've experienced. And I'll never forget when I ran my first neural network, which was a simple classifier that was boxing things. And I've been working with image recognition even since 1980s when we started. And with traditional image recognition, you get something work for a few minutes, and then there's a cloud on the sky and you have to adjust something. But this neural network, it tracked me wherever I was in the room or in the whole office, and then I just turned the light off to leave. But that machine still tracked me in the darkness. Mm-hmm. And then there was a small box that I hadn't seen before, that it had sort of boxed within the image and potted plant. And at that moment I heard myself saying, okay, how the heck did you know that? Mm-hmm. And I think that's the first time I ever even talked to a machine, except for the Alexa and Google Home maybe. But so, okay, systems normally don't impress in that direction. They bother you and they make you more or less irritated. But this is so I'm happy going to the job, working with neural networks. Yeah. But I'm really looking forward to see where these embedded devices will take us, because I'm a builder. Yeah. From as I was a kid, I like to build stuff, and then I'm also really interested in seeing. We're right now looking into the opportunity of creating synthetic data. Mm-hmm. A lot of people knows that data might be a key. You need tons of data, and you also need the ground truth for the data. So you train to teach the network identify cats. You need 50,000 images of cat, and you need to tell the system this is a cat and that's a dog, and that kind of data is still valuable, and many businesses are actually sitting on tons of valuable data that could be a goldmine for them, and maybe even be a valid resource when young, fresh companies are competing with brand new ideas, but they might have the data. Yeah, data is correct. And but if you don't have the data, or if you're trying to do something outside the standard domain, you need to find training data if you're going to use supervised learning. And one way, really interesting way, is to simulate that data from a graphic system like a game engine. There are Unity from, I don't know if it's Windows, and there's the Unreal Engine. Free tools, extremely powerful. And so that's a resource and a skill we're building within the company right now, to have a more or less a method and a step-by-step method that's well working to create new data for customers. And we're looking into the simulated data, the synthetic data thing, because the data will be autonomously or automatically annotated as well, since the computer is God and knows all about the things. So that's going to be interesting to see if we can.
And I'm sure very impactful for business, like generate their own.
Yes. And so that's one of these. And then, of course, another thing that is almost shocked me. I think it was Thursday or Friday last week when Google announced their success with their quantum computer. So they claim that they had a quantum computer with 53 bits, or I don't know, quanions, or what do you call these quantum bits, and they had it running for 200 seconds. And it made calculus that would have taken 10,000 years for the biggest computer in the world to do the traditional way. So that's both inspiring and shaky. They're going to crack all the RSA keys and just like that. So, and of course, I don't know if that's applicable for AI and machine learning, but I guess.
Still exciting. And still new enablers that will impact both tech development and
quantum leap, to be funny. And maybe, it could be a game changer. And who knows where that will end with. And I remember the first computers, they were also extremely advanced for the man on the street. Now they are quite simple because everyone has taken some computer courses, and this quantum computer is of course extremely complex and hard to understand for the common man.
Yeah.
Let's see what's happening in 20 or 15 or 10 years ahead.
Yeah, I think that's a very good note to end at. What's happening, like.
Okay.
And thank you for a very inspiring talk on what you do and how it can enable new business modes, but that there's still some obstacles that we need to work with. Patient, yeah. You
have to be patient, and you have to think really carefully.
Yeah.
What about the customer's domain, and try to adopt your message to their domain and to their knowledge, and that might be the way to get into business.
Yeah, perfectly summarizing.
Yeah.
So thank you for your time, Hans.
My pleasure.
And thank you, listeners, for listening. Please subscribe to whatever platform you are listening to. Keep an eye out on social media. I guess we're going to show up there sooner or later. And if you have any questions to us or to Hans, send them to us at businesstechtimes@gmail.com. We'll answer you there, and keep an eye out for the next episode. So thank you again, Hans.
Thank you.
And thank you all for listening.
So in the discussions with Jonatan, I was talking about embedded devices running neural networks. And this little box that could be mounted in a DIN rail in an electrical cabinet is actually running a small Linux platform, and we're using the latest embedded neural processing chip from Google called the TPU within, and it's running a trained network that's capable of distinguishing between, I think, 2,300 species of bird. And I'll see if I can illustrate that to you. So let's look at the magpie, as we in Swedish call it the skata. And so there we have the Eurasian magpie is the classification, fairly good. And then just to see that it's not that particular skata. So this is another magpie. Come on. Eurasian magpie. And then we have a popular Swedish bird, maybe the best looking or most colorful bird we have in this country is the blue tit, or the blåmes as we call it in Swedish. And that should end up as a blue tit, the Eurasian blue tit. And then it's often mixed up with the talgoxe, the great tit. And the network is capable of distinguishing between these two birds. So that's it. The neural network processing unit, the TPU from Google, running on a small Linux embedded platform.